I am Prabhakar. Today we will be discussing the property of addition and subtraction of vectors. Consider a vector A and vector B. How do we add these two vectors? Vector B and vector A are given. Now, you draw vector parallel to B at the head of A. This length and the direction should be same, but parallel to B. This is vector B, which is the beginning of vector B should be at the end of the vector A. Then this vector is A plus B. This is called the triangular method of addition of vectors. See, what was given was vector A and vector B. What we have done to add the vector B to vector A is transferred this vector B, so that the tail of this vector B has the starting point as the head of A. This is called head tail method of adding vectors. This process is called triangulation of vectors. If two vectors are represented by the two sides of a triangle, then the third vector, which is here, is the sum of these two vectors, vector A plus vector B. Now, if I draw a vector parallel to B of the same magnitude, but in the opposite direction, we call this as negative of the vector B, because it is anti-parallel to the direction of B. If you want to add vector B minus B to vector A, how do you do it? Do by the same method. First, transfer vector A, let us say at any point. The length should be same, ensure that the length is the same. It should be in the same direction and it should have the same magnitude. This is vector A. You have to add minus B to it, ensure that the tail of this vector minus B is at the head of vector A. What we do is draw parallel at this point and have the same magnitude wise. So, this is vector minus B. Now, starting point to the ending point of minus B, this is vector A minus B. How did we get this? What we have done is, we have added vector A to negative of the vector B, and we write it as vector A minus vector B. So, we have done the additional operation of vector A to B and also the subtraction of vector B or addition of vector A, and with the negative of the vector B, we have vector A minus B. This is one method of vector addition, that is the graphical method of vector addition. That is, you can do this vector addition in a different way. Let us take vector A and vector B. If it is given like this, you can do it by the method of triangulation, which I have said. You can do it also by another method, what is called the parallelogram method of vector addition. Now, what is that? Construct the parallelogram with A as one side and B as another side. How do you do it? Transfer this vector A to some other point having the same magnitude and the same direction. So, this is vector A. Vector B also should be transferred, but here vector A and vector B as two sides of the parallelogram. Complete the parallelogram. How do we do? Draw a line parallel to this. This is vector B and this is vector A. A plus B is A plus B. This is the vector A plus B. Now, in the parallelogram method, the two vectors are represented by the two sides of the parallelogram. The diagonal passing through that common point of these two vectors is the sum of these two vectors, which is A plus B. You could have done this by the triangular method also. I will just show you how the same thing you would have got by the triangular method. You have this vector A and you have vector B, that is the head tail method. Then you have this vector A plus B. So, whether it is by triangular method or by the parallelogram method, you get the same vector. Now, in the parallelogram method, what you need to do is they should have the same common point. Here, that is vector A and vector B are two sides of the parallelogram. Complete the parallelogram, the diagonal passing through that point and ending there is represented as A plus B, which is the same as in the triangular method vector A plus B without the completion of the parallelogram. Now, this becomes the same thing whether it is A plus B or B plus A. In the parallelogram method, you can see that vector A plus B is vector A plus B. Here also vector B is added to vector A, you get the same. So, the vector A plus B is the same as vector B plus A, that you can see it very clearly in the parallelogram method. That is, vector addition is commutative. So, if you want to call something as a vector, the additional property either by the method of triangulation or by the method of parallelogram must be satisfied. Consider the vector A, which is as shown. What is meant by 2 times this vector? That is 2 being a scalar. 2A, what does 2A mean? How do we represent it? Doubling this vector means the magnitude will be double, the direction remains the same. For example, in this case, I am going to indicate, for example, 2A as the same vector having double the magnitude. That is multiplication of a scalar with a vector. What do you mean by minus A? Multiplying this with the negative, that is minus 1. So, this is minus A. That is, these two vectors have the same magnitude, but their directions being opposite to each other. When you add a vector to its negative vector, when A plus minus A, vector A plus of minus A, what do you get? You get 0. Is it a scalar? Now, we call this as a null vector. What is its direction? It could be in any direction, because A plus A or B plus minus B, we gives you null vector. Null vector does not have a direction, but why do you call it a vector? Because we have to define what is called as negative of a vector. A not equal to minus A means A and minus A are opposite, but when you say A plus of minus A is 0, That is how the negative of a vector is defined, that is multiplying vector with a scalar and that is minus 1, then a plus of minus a is 0. We call that as a null vector. Null vector has 0 magnitude, direction is not very specific. Now, what do you mean by saying null vector does not have a direction? I will give you a simple example in the case of a displacement vector. Let us take an object has moved in this direction, say 10 meters. If I come back from this point along the same path, it means I am adding a displacement vector of minus 10. The addition of these two displacements, that is 10 meters along a particular direction and 10 meters in the opposite direction, 10 meters in a certain direction plus of 10 meters in the opposite direction. Now, this is addition of displacement. The net displacement is 0, that is 10 meters along a certain direction, say along the direction of whatever the vector, if I call this as the direction indicated by plus, this direction is minus. The addition of these two gives you a null displacement, but the distance travelled, please note 10 meters has travelled along this direction, it has travelled 10 meters along this direction. The distance travelled is 20 meters, but the displacement is 0. That is the distinction between displacement and distance travelled or length of the path. This is very important to understand that displacement is a null vector here. Direction none. It could have happened here in this direction also, then you get 0, but what is its direction? Direction is not specified. Null vector has no specific direction. Till now we have considered addition of vectors a and b, vector a and b by method of triangulation or by the method of parallelogram. It could be done in a different way, which is called the analytical method of addition of these two vectors. Now, what is analytical method of addition of these two vectors? Vector a is decomposed into two vectors, just like we have added two vectors and we have got the resultant vector. That is, when you add two vectors, you have a resultant vector a plus b, a and b, you have a plus b as a resultant vector. Now, the resultant vector is the sum of two vectors. Now, here the given vector itself will become the resultant. How? Let us say that this is the given vector. Now, this vector, let us say in this plane I draw two axes perpendicular to each other. Let us call this as the x axis and call this as the y axis. This vector a can be considered as sum of two vectors which are perpendicular to each other. How? Just drop a perpendicular to this x axis. Similarly, drop a perpendicular to the y axis. Now, call this as a x vector, this as a y vector. Now, do you see that this vector a is decomposed into two vectors which are mutually perpendicular to each other, and the vector along the x direction is called a x vector and vector along the y direction is a y vector. A x vector plus a y vector is vector a. This is called the component method of addition of vectors. You can consider this as a x vector as one vector along the x axis, a y vector as another vector in the y axis. Now, the addition of these two vectors results in a vector a. Now, a x vector and a y vectors are called the component vectors of a along the direction of x and along the direction of y respectively. So, vector a has been decomposed into two vectors which are mutually perpendicular in directions, and these two are called the component vectors in these directions. So, a vector A has been resolved or decomposed. Ax is called, this process of decomposing or resolving a vector into two component vectors is called the resolution of vector A. We have used the property of vectors addition to do vector addition. We can either go by the triangular method or by the parallelogram method. We can also use the analytical method of or the component method of vector addition, because here itself vector A is a result of vector Ax plus vector Ay. So, this is called the component method of vector addition. We will do how to add two vectors A and B by the component method in the next class.